Hello, everyone. This is section 1.6. Uh, so this is going to be, well, we're still second week. So yeah, second week. This is Thursday lecture. But before I start the lecture again, I want to remind you guys about the quiz. So, okay, so this is since this is 1.6, so 1.6 quiz, if I assign. So you have to watch the whole videos like I've been saying every time you have to watch the whole video. And if I assign any quiz in this video, and since this is a Thursday lecture, so like I said, if this is a Thursday lecture, then the due of the quiz is on the next day. So that's why the due of this quiz is going to be on Friday, midnight, right? Which is August 28th. And similarly, I have also emailed about the web assigned homework, and also you can find this. I've also made an announcement in the Blackboard, all right? So like I said in the introduction video, if you miss or if you don't get my email or anything like that, pretty much everything is in the Blackboard, all right? Um, so when you click this course, yeah, I have made an announcement. So this was about the office hour. Yeah, office hour. My office hour is only Monday and Thursday. All right, keep that in mind. It's not Monday, Tuesday, and Thursday. Well, our regular class is Monday, Tuesday, and Thursday, but my office hour is just Monday and Thursday during the regular class time. And yes, I made about announcement about the homework as well. And also, I think I sent an email about this. But anyway, just remember that the web assigned homework, if you haven't done this, the web assigned homework of section 1.2, 1.3, and this was basically I just combined these two one video, so there is just one homework of this section, these two combined sections, so which are going to be this coming Saturday, which is August 29th. All right, so now I think, yeah, that's what I want to talk first. Now let's start this section. Let's start with different properties of or different laws of a limit. All right, so the limit, first it says that, okay, if we take the limit of, let's say there is f of x plus g of x, or it could be f of x minus g of x. For both a plus and minus, we're gonna get the same properties. All right, so if there's a single limit for these two, there is a big parenthesis, right? Then I can split this into two different terms like this. And if there is a plus in the middle, we're gonna get plus. If there is a minus, then we're gonna get minus. Simple, right? So let's say if I have a limit of x goes to, let's say, 2 of 2x plus 1, or 2x plus, let's just say, x. Then in this case, there is a single limit with two terms. Then I can split this into two terms like this. So limit of x goes to 2 of 2x plus limit of x goes to, I mean, in this case, you could have just said 2x plus x is 3x, but let's just say 2x square. So that way we cannot combine these two, right? 2x square. X, like this. And then now just take the limit of this. So x goes to 2. So in this here, since this is just a number, so we are multiplying. So this property is basically a second one. All right. So if there is, let's say, if c is a constant, if this c is a constant, that means c can be any number. Then in that case, I can just take out c out of this limit and just take the limit of just the function. So I can do the same thing here. Just take out this 2 out and just take the limit of x square. So since x goes to 2, so 2 times x goes to 2, so this x goes to 2, so 2 square, right? And since I have a plus here, so plus x goes to 2, there is just x, so x means 2. So here we'll get 2 squared is 4, 4 times 2 is 8, 8 plus 2 is 10. right? So yeah, I just showed this thing here. So it's just that, let me just do it one more time. So if x goes to 1 of, let's say 3x to the power 4, something like this, then in this case, I can just take this 3 out, just take the limit of x to the power 4. But since x is 1, so 3 times 1 to the power 4 is still 1. 3 times 1 is 3, right? Yeah, simple idea, but this is very useful to solve some complex problems, all right? So that's why we need to know all of these ideas. All right, so similarly, again, we have two functions. Now in this case, we are multiplying these two functions. All right, so if you're multiplying these two functions with a single limit, then again, I can split this into two terms. And again, there is going to be multiplication in the middle. Okay. Similarly, for division, again, we have a single limit, f of x divided by g of x. So again, I can split this into two, limit on the top, limit on the bottom. But here we got to make sure that this limit on the denominator is not 0. All right. The reason for that is if we divide anything, any number, doesn't matter, any number by 0, it's always undefined, right? Anything, I don't know, let's say star, anything, there can be anything on the top, divide by 0, then this is undefined, right? So that's why we have to make sure that the denominator is not 0. If we get a denominator 0, then there are different process of getting the answer, so which I will talk later. But yeah, it's just that the denominator cannot be 0. Similarly, when I'm taking the limit of f of x to the power n, then in this case, I can just take the power of n for the whole limit. Okay, so it's just like limit of x goes to 2 of x squared. Then I can also write this as limit of x goes to 2 of x. And this thing on the power, I can just simply take the square of this whole thing. And if I say limit of x goes to a of c, where c is a constant, so this is like, again, if I take the limit of this, this is still c, which is similar to, let's say, x goes to 1 of, let's say, 4. So if I'm taking the limit of this, so since there is no x here, right, we're saying x goes to 1, but there is no x here. So in this case, the limit of this will be just whatever number we have here. So since we have a 4 here, so this is just going to be 4. All right, so yeah, these are the basic properties we should know to do more stuff or more problems in limit. All right, so okay, let me do examples. So let's do some examples. So the first one, let's say if limit of x goes to, let's just say 3 to x plus 5. Right, so I did something like this here, right? So again here, I can now split this limit into 2, right? So limit, so make sure you, okay, so we haven't used the limit here yet. So you have to include limit every time, okay? To make this thing mathematically correct, all right? Since we are doing math, so it has to be mathematically correct. So now if I split this into two terms, it will be limit of x goes to 3 of 2x plus limit of x goes to 3 of 5, right? I mean, probably these kind of problems, you can just get the answer or even without doing any work, right? But But when I check your problems, I should understand, or I should know that you know this thing, right? You understand this thing. So to make me well, as a student, you have to show me your work so that I know, okay, you guys are understanding things. So that's why you need to show your work, even though you can get the answers within like few seconds, but still you have to show your work. So that I know, okay, you are understanding the problem. All right, makes sense? Okay, so now again, if you take the limit of this, like I said, I can split, well, take this 2 out since we are multiplying these two. So I can take this 2 out and just take the limit of just x, which will be just 3, right? Because this x goes to 3 plus a limit of x goes to 3 of 5. But since there is no x here, so it will be just 5, right? So 6 plus 5 is 11. Right, so let me do here, second one. So let's say limit of x goes to 2 of x squared plus 2x minus 1 over 8 minus 3x. All right, so here, when you're working with a division or with a fraction, right? I said one property is here. So when you're working with the fraction, then you have to make sure that the denominator or the limit of the denominator is not 0. Okay. So first thing, what I can clearly see that is if x goes to 2, if x goes to 2, then the denominator is at 0. Well, 8 minus 3 times, well, x is 2, so 3 times 2 is 6, so 8 minus 6 is not 0, right? So that means in this case, it's going to work. So, okay, now using that properties, I can now say the limit of numerator is x, limit of x goes to 2 of x squared plus 2x minus 1 divide by limit of x goes to 2 of 8 minus 3x. Make sure you have this parenthesis so that you know that you're taking the limit of this whole thing. Okay, now okay, so now I can split this into, well, since I have a 3, yeah, you can do that, but I'm just going to skip that since I already did that. So limit of x goes to 2, so here it's going to be 2 squared plus 2 times 2 is 4 minus 1. Similarly on the denominator, again it goes to x minus 3 times 2. Okay, so in the numerator we get 4 plus 4 is 8 minus 1 is 7, and denominator 8 minus 6 is 2. All right, so this is the final answer. All right, so yeah, when you do these kind of problem in the exam, make sure you show some work. All right, do not just write from here to here. All right, from here to here, that doesn't make sense. Maybe you know it, but you have to convince me, okay, I should know that, okay, you are understanding the problem. That's why I said you need to show your work. All right. Okay, now let's see what I have here. Oh yes. Let's take the limit of x goes to 2 of x squared minus 4. This is example number 3. X squared minus 4 over x minus 2. All right, so like I said, when you're doing with the fraction, when you deal with the fraction, you have to make sure that the denominator is not 0. But here we can clearly see that when x goes to 2, and the denominator will get this x is 2, right? So 2 minus 2 is 0, right? So that means anything, doesn't matter whatever we have on the top. So anything divided by 0 is, like I said, it's undefined, right? So now here, if we just take a limit, it's not going to work. But here we can still make this thing work. How? Well, I think I showed this on one of the videos. I don't remember, one of the algebra review video. I think so. Or no, it was, sorry, it was in the last videos. Yeah, where if you have a square minus b square, or if you're subtracting 2 square, then you can also write this as just a plus b times a minus b, right? So this is a formula. This is a formula from algebra. So here, well, we can do same thing here. So x squared minus 4, we can also say that x squared minus 4 is 2 square, right? So that way we get, we're taking, well, we are subtracting 2 square, right? So that means from here now I get x plus 2 times x minus 2, right? So now I can say that, okay, make sure, like I said, make sure you write limit here again, because I haven't used the limit yet. So limit of x goes to 2. On the top, it's x plus 2 times x minus 2 over x minus 2. Right? So this way, this x minus 2 and this x minus 2 cancel. So that way we just have a limit of x goes to 2 of x plus 2. Right? So now it's just simply that this x goes to 2. So 2 plus 2 is 4, right? Okay, so yeah, if here with this one, there was no 0 on the denominator, so I can simply just take the limit of numerator and denominator and get the answer. But here, if you just directly use the limit, then the denominator is 0, which is going to be undefined. So that's why I factor out this on the top and I cancel this, and then after that I get the answer. Okay. All right, now let's see. Okay, let's see. Let's see one more. Let's say, okay, let's say limit of, now let's say, instead of saying x, let's say h goes to 0 of 2 plus h square minus 4 over h. All right, so again, when h goes to 0, okay, the denominator is 0. We can directly see that easily, right? So that's why the denominator is undefined, or this whole thing is undefined. So that's why now what we can do is let's expand this. Let's find, let's see what we can do with the numerator, and let's see if we can cancel something from numerator and denominator. So let's first expand this. 2 plus h square. So 2 plus h square is similar to, let's say, a plus b square. Again, we know the formula of this. Again, this is from algebra, but still, I'm going to say this one. A plus b square is a square plus 2 times a times b plus b square. Right? So using this formula, so I will get a square here. A is 2, so 2 square is 4, plus 2 times a is 2, times h is b, right? Plus b square is h square, right? So that means I can substitute this thing here. So limit of h goes to 0 on the top. For this one, 2 plus h square, I got 4 plus 2 times h is 4h plus h square minus 4 over h, right? So now this way, here on the top, I can cancel positive 4 and negative 4. So that means on the top, we just have h square plus 4h over h. And also now here, I can, on the top, I can factor out h, right? So the limit of h, that goes to 0. If I factor out h, then I just have h plus 4 over h. So these two are gone. All right, so that means now since h goes to 0, so h goes to 0, so 0 plus 4 is just simply 4. Okay. Okay, now let me introduce a theorem. Okay, so this theorem is very useful theorem. If you take some higher level math course, this is very useful. Okay, there is a course called Advanced Calculus. This one is just calculus, but there is a course Advanced Calculus. So this idea is very useful on a higher level math course. All right, so this theorem is called squeeze theorem. So the squeeze theorem says that, okay, let's say if we have three functions, okay, so three functions f of x, and let's say this f of x is less than equals to another function, let's say g of x, and this is also less than h of x. Okay, so basically the reason we're saying squeeze theorem is we can see that this g of x is squeezed in between this f of x and h of x, right? Okay, now if we know this, and also let's say if we know the limit of this function and this function, but we don't know the limit of this function. All right, so we know the limit of this function, we know the limit of this function, but we don't know the limit of this function. So let's say if the limit of, let me use blue. Yeah, the limit of, it's x goes to a of this function f of x. Okay, and the limit of this function and limit of this function, let's say these two are actually same. H. Okay, so limit of this and this are same, and the value of this both is L. All right, then since this is a squeeze between these two, so this is less than, or this is greater than f of x, this is less than g of x, and both of the limit of this is that goes to L, limit of this goes to L. So then we can automatically say that the limit of this that is in between is also L. Okay, so yeah, understand this this theorem. Okay, so I might ask something related to this theorem in the exam. Okay, I don't know what I'm going to ask, but if you understand this idea, you can definitely do the problem I ask in the exam. Okay. Okay, so now using the concept here, using this concept, let's do a problem. But before I do the problem, let me just say one more thing. Okay, so let's say, let me introduce a trigonometry. Okay, so the trigonometry, I guess you guys have already taken the trigonometry class. I think you guys are required to take the trigonometry, right? So let's say a sine of something, I don't know, anything. Let me just put this blank here. There can be anything. So the sine of anything. So from sine, if you just enter in a calculator a sine of anything, you're always gonna get the value of this in between -1 to the +1, okay? So anything, sine of anything is always this. So this is a fact. It's same thing for cosine as well. Cosine of anything, you always get the value in between this. Okay, so this is a fact, right? So I'm not gonna go too much detail into this fact. Okay, so this is gonna be a trigonometry class stuff. So I'm just gonna use the fact from the trigonometry to do the next problem I'm doing. All right, so let's just, you just need to know this fact, all right? So using this fact, now let's find the value of x goes to 0 of x squared of sine 1 over x, right? X times sine 1 over x. So here, what we can do here is, well, if you see that x goes to 0, that means this is 0 squared times whatever is there. It should be 0, right? But the thing is here, we cannot say 0 here directly like this. We cannot say that. That's not possible. All right. The reason we cannot say this is because, okay, let me just erase this. That's not possible. Well, like I said, in the math, you always need to show your work to justify your answer. All right. So if you don't have correct correct work to justify your answer, then you are wrong. Even though you get the right answer, but your work is not correct, that means you are wrong. All right. So that's why here the reason I cannot say that is here. If you see this, if I say x goes to 0, that means it will be sine of 1 over x. So if I'm getting 1 over x, which is x goes to 0 means 1 over 0, which is undefined. So we have undefined functions. So that's why if we have undefined function, we cannot say, even though this is 0, x squared at 0 squared is still 0, we cannot say that this whole thing is 0. So that's why here we're going to use the squeeze theorem. All right. So what I'm going to do here is, since we have a sine here, so let's say sine of 1 over x, like I said, from sine, we always going to get the value in between -1 and +1, right? Now, what I can do is, well, since we were taking the limit of this, right? Taking the limit of this. Now, here in the middle, well, if I can say this goes to something, if this goes to something, if these, the value of both of these are same, then the limit of this thing in the between should be the same, right? It's using the squeeze theorem I just explained here. So now, since I'm missing x squared, so let's just multiply each of these by x squared. So here, multiply this, I can do that, right? So again, this is algebra, so I can multiply this by x squared. So x squared times -1 is -x squared, less than, here, multiply this by x squared. Is less than equals to, again, x squared, right? So there you go. Now, now if you can say the limit of this and the limit of this are same, then it should be the limit, whatever the limit we get. But now let's say the limit of this, limit of we have x goes to 0, right? So the limit of x goes to 0 of this negative x squared is, so x goes to 0, there is a negative, so negative x goes to 0 means 0 squared is still 0, so negative 0 is, well, we can just say this is 0. Negative 0 is still a 0, right? So that means this goes to 0. Similarly, now let's take the limit of this. This goes to 0. All right, so again, you have to show your work. All right, do not just say this is equals to 0. So you have to justify your answer. All right, that's why I said if your work is not correct, even though you get the right answer, you are wrong. You are still wrong. Okay, now after this, okay, so the limit of this is 0. So the limit of this is 0. So since this thing is squeezed between these two, so using the squeeze theorem, using a squeeze theorem, let me just write THM, then I can easily say that this limit that x goes to 0 of x squared sine 1 over x is also 0. Clear? So yeah, I'm just using the squeeze theorem to prove this. All right, so in the exam, if I asked you to, okay, find the value of this using squeeze theorem, then you have to use the idea of the squeeze theorem. If I ask something similar, I may not ask exactly the same, but I might ask something similar in the exam, right? So you have to use this process, this idea, or you have to sum your work, something like this, to justify your answer. All right, so that's all I have for this section. So like I said, this is Thursday lecture, okay? And then, all right, yeah, I'll see you. And yeah, just remember the announcement I made earlier about the quiz, about the homework. If you watch this whole video, then probably you just found it, whether I assign any quiz in this one or not, right? And also make sure that you submit or you do your web assigned homework by Saturday midnight. Okay? Okay, I'll see you in the next video. Thank you.